Okay, so question 1, right, okay, you have to prove it's true for n equals 1. So that means, or sorry, look at that, it's n equals 3. Okay, so prove it's true for n equals 3. So everywhere I see an n, stick in a 3. So it's 2 to the power of 3 plus 1. And that's 8 is greater than 7. And that's a true statement, so that's done. Right? Then you assume it's true for n equals k. So you're trying to prove that 2 to the power of k, or sorry, this is a fact. 2 to the power of k plus 1. Fact. That is true. Right? Then you have to prove it's true for n equals k plus 1. So you're trying to prove that 2 to the power of k plus 1 is greater than 2 to the power of, 2 times k plus 1 plus 1. So that's what you're trying to prove. So is this true? You know this is true. So is this true? Okay, so for your proof, guys, we start off with the true statement. So proof. So we know that this is true, greater than 2k plus 1. Okay, right. If we multiply each side by 2, so 2 multiplied by 2 to the power of k, it's still true. Okay, so I've multiplied both sides by 2 and it's still true. So this is 2 to the power of k plus 1 is greater than 4k plus 4. This is true. This is a true statement. Okay, so what I can do now is, can I say that, if I can say that 2 times k plus 1 is, if I can say that 4k plus 4 is greater than 2 times k plus 1 plus 1, right, it's, the whole lot is true. So let's multiply out and see what's going on. 2k plus 2 plus 1. So moving that to get around, that would be 2k greater than minus 1. Have I done something wrong there now? I feel I have. Where did I get this 4k plus 4? Yeah, there. Right. No, I think I'm okay. So, and is 2k greater than minus 1? Yes, it is. Right, because k is always 3 or more. That's what the sum says. So, therefore, your statement 2k plus 1 must be greater than 2 times k plus 1 plus 1. And then off you go and write your 4 sentences. True for n equals 1, true for n equals k, true for n equals k plus 1. So true for n, for all n where n is greater than 3. Okay? Right. So number 2. Right, so number 2, right, okay, so let's prove it's true for n equals 2. So that means everywhere I see an n, stick in a 2. So that's 3 to the power of 2 is greater than 2 to be squared. Sorry, I'm just checking is there on that. No, just greater than 2 squared. So 3 squared, sorry, no, that's right. Yeah, so that's 9 is greater than 4, and that is a true statement. So I proved it true for n equals 2. Assume it's true for n equals k. Right, so that means everywhere I see an n, stick in a k. So 3 to the power of k is greater than k squared. Right, as far as I'm concerned, that is true. Now prove it's true for n equals k plus 1. So what am I trying to prove? I'm trying to see is 3 to the power of k plus 1 greater than k plus 1 to be squared. Okay, so that's the question. So start your proof, right? Okay, so you always start your proof with the true statement. So the true statement is 3 to the power of k is greater than k squared. Okay, this is what I'm heading for. I'm trying to look at this. Right, okay, so if I multiply both sides by 3, I still have a true statement. Okay, so this is still a true statement. So 3 to the power of k plus 1 is greater than 3k squared. That is a true statement. So if I can prove that this term here, if this, right, is greater than this, I have it proved. So if I can prove that 3k squared is greater than k plus 1 to be squared, then I have the whole lot proved, right? Because that is true. So if this is bigger than that, then this statement is true. So square it out. 3 squared k squared greater than square the first, twice the first by the second, square the last. Bring everything over to the left. So we have 2k squared minus 2k minus 2 is greater than or equal to 0. I could divide everything by 2 just to make life easier for myself. Right, okay, sorry, that should be a plus 1. So I can't divide everything by 2 because that's minus 1. Okay, so what we need to do here, guards, is complete the square. Right, so take out the 2 and I'm left with a k squared minus k minus a half. Okay, complete the square here. Right, so I have 2 times k squared minus k, halve it and square it. So half that's a half, squared is a quarter. But then I need to take off a quarter and I need to take off a half. Okay, so that would be k plus a half to be squared. And there's a 2 in front of it. That would be minus 3/4 multiplied by 2 is minus 6/4. So this is definitely positive, right? Okay, and if n is 2, the smallest n is greater than or equal to be 2, right? Okay, that's definitely true. So then if that's true, you can say the whole statement that 3 to the power of k plus 1 must be greater than k plus 1 to be squared. Okay, so when you fill in here, you just fill in for k. The smallest k can be is 2. So if it's true for 2, it's true for everything. So fill in 2 for k and work it out. It will be greater than 0, right? And then it's true for everything. So if it's true for 2, 2 is the smallest number k can be according to the sum. Then write your 4 lines. True for n equals 2, true for n equals 2, true for n equals k, true for n equals k plus 1. Okay, that's number 2. Right, number 3. It's 3 to the power of n is greater than 2n plus 2. Right, so prove it's true for n equals 2. So n equals 2. So that's 3 squared is greater than 2 times 2 plus 2. So that's 9 is greater than 6. That is a true statement. Right? Assume it's true for n equals k. So 3 to the power of k is greater than 2 to the power of k plus 2. This is a fact. Right? Okay. Then you want to prove it's true for n equals k plus 1. So everywhere I see k, put in a k plus 1. So is 3 to the power of k plus 1 greater than 2 times k plus 1 plus 2? So this is what I need to check out. So start your proof with a true statement. So my true statement is 3 to the power of k is greater than 2k plus 2. Right? Now, to make it like this, I multiply each side by 3. So that's 3 times 3 to the power of k is that greater than 3 times 2k plus 2? So 3 to the power of k plus 1 is greater than 6k plus 6. This is a fact, okay? So this is a fact. So if this is greater than what I'm trying to prove, I have the whole lot proved. So if 6k plus 6 is greater than 2 times k plus 1 plus 2, I have everything proved. So multiply out 6k plus 6, is that greater than 2k plus 2 plus 2? So that would be 4k plus 2, is that greater than 0? And yes it is, because this is positive, so the whole lot is positive. So therefore 3 to the power of k plus 1 must be greater than 2 times k plus 1 plus 2, and then you write your 4 sentences. True for n equals 1, true for n equals 2, true for n equals k, true for n equals k plus 1, so true for all n element of n where n is greater than or equal to 2. Right, last one, number 4. So prove it's true for n equals 3. So that's 3 factorial is greater than 2 to the power of 3 plus 1. So 3 factorial is 3. Now, there's something wrong here. I must have written it down wrong, did I? Oh yeah, the n plus. I know I wrote it down wrong. It's a minus 1. Right, okay. Yeah. I think it could be, yeah, it's a minus 1. Right, okay. So is 3 factorial is 3 by 2 by 1, which is 6. Is that greater than 2 to the power of 2, which is 4? Yes it is. So that's a true statement. Right? Assume it's true for n equals k. So that means fact k factorial is greater than 2 to the power of k minus 1. Okay? Right? That's a true statement. Prove it's true. Right? So I need to prove for n equals k plus 1. So the question is k plus 1 factorial greater than 2 to the power of k plus 1 minus 1? Okay? Which is just 2 to the power of k. Right? Okay. So off I go with my proof. So again, I start with my true statement. Okay. So I know that k factorial is greater than 2 to the power of k minus 1. If I multiply each side by k plus 1, so multiply k plus 1 multiplied by k factorial is greater than 2 to the power of k minus 1 multiplied by k plus 1. Okay, so this will be k plus 1 factorial is definitely greater than 2 to the power of k minus 1 multiplied by k plus 1. That is definitely true. So if this is greater than this, I'm good. So 2 to the power of k minus 1, where am I? Multiplied by k plus 1. If I can say that that's definitely greater than 2 to the power of k, when I simplify that it became 2 to the power of k, I'm good. Right? Okay. So what I'm going to do is I'm going to say this is 2 to the power of k minus 1. This is k plus 1. Over this side, I'm going to break that up into 2 multiplied by 2 to the power of k minus 1. Is that okay? Then I'm going to divide each side by that. So is k plus 1 greater than 2? And yes it is, because the lowest number k can be is 3. So 3 plus 1 is definitely greater than 2. So yes, that is true. So if that is true, I can say the whole lot is true. So k plus 1 factorial is greater than 2 to the power of k plus 1 minus 1. Right? Okay? So then you write your 4 sentences. True for n equals 3, true for n equals k, true for n equals k plus 1, therefore true for all n element of n's where n is greater than or equal to 3.